let's quickly go through what we had discussed in the last class. Last class we discussed how to derive the equation of path followed by an object which is moving in 2 dimensions, moving on a plane. And see, the plane on which it is moving or in which it is moving, we took that as the xy plane, right? Any path in the xy plane can be represented by an equation which is basically a relation between the x coordinate and the y coordinate. So that's what our target was, relating the x coordinate and y coordinate of the particle. And for that, what we did, we first discussed on what the shape of the path depends. Okay, how an object moves, not just in this case, in any case, be it 1D, 2D, or 3D, how an object moves depends on its velocity. And we know velocity is influenced by acceleration. So it depends on acceleration also indirectly. So to derive the equation of path followed by an object, you need to know where it is starting from, with what velocity it started, and what happens to that velocity later. That you can tell from acceleration. So you need to know position, velocity, acceleration to derive the path. And those are the kind of questions that we discussed in the last class. We visualized first how the object should move. If we know that if velocity and acceleration are in the same direction, the object continues along the same direction. It moves on a straight line. Fine. And if they're in opposite direction, we know it stops. I mean, it slows down, stops, and then moves in the opposite direction, but it's still on a straight line. Then if they're in different directions, then it'll follow a curved path. All those, first we visualize that, then we actually derive the equation. Nitya, good evening. We are just going through what we discussed in the last class. I had taught them how to derive the equation of trajectory or equation of path followed, generally in 2 dimensions. Okay.
Okay, sir.
So we took examples where we considered some initial velocity, acceleration. First, we visualized whether the path will be a straight line or not. Okay. Then we actually derived the equation, and the equations proved what we visualized. Okay. Fine. So general procedure that we follow is that we write the x coordinate as a function of time. For example, in this question, we write x as a function of time, y as a function of time, and then we try to eliminate t from those 2 equations such that we relate x to y. Okay. And when x is related to y, that itself becomes the equation of path or trajectory. Okay. Fine. So yeah, before equation of trajectory, we had discussed ground to ground projectile, how to find out H max, range, time of flight, how to tell about anything during the flight, what angle the velocity makes at a certain time, at a certain height, such things we had discussed. In this class, we will discuss some other cases of projectile motion in 2 dimensions. Okay. For example, just a moment. Consider this case. Yeah. There is a ball on a table. Fine. You push the ball, give it some velocity in this direction. Let's say the velocity is u, and you release it. Okay, you can even imagine the ground if you want. Pawan, tell me, what will happen to the ball after it is given some velocity like that and released?
bench ending వరకు వెళ్తుంది నాకు.
Okay. It rolls till the edge of the table and then it falls off. Fine. Now, till it reaches the edge of the table, how does it move? Like, what kind of path does it take? Till it reaches the edge of the table. Okay, anyone else? Aishwarya, Nitya?
It follows a
straight
straight line.
Okay, Nitya says it follows a straight line. Pawan, what are you saying?
Same, sir.
Same. Yeah. Let's assume the table is smooth. Let's not consider the effect of friction as of now. So it follows a straight line path. till it reaches the edge of the table. Okay. One of you tell me, if we don't consider friction, that means if we ignore friction, will anything happen to its velocity, or will it move along the table with constant velocity?
Yes, sir. It would move with constant velocity if there is no friction.
Huh. We ignore friction, air resistance, so it will move with constant velocity. See, I told you, Nitya, you have been through all this. You know, the other students are like first year students, so this is the first time they are studying all this. See, we had discussed before that velocity of an object will be disturbed if it has acceleration. And we had briefly talked about this also. Object accelerates when forces act on it. Okay. Now this ball, as it moves along the table, there will be gravity acting downwards, and the table is supporting it. That's fine. But horizontally means parallel to the table, there's no force acting. So nothing is there to disturb its velocity. It will continue with that velocity till it reaches the edge of the table. Okay. Aishwarya, tell me what will happen after it reaches the edge of the table. We had just discussed that it will come to this point with the same velocity u. So when it reaches the edge also, it has that velocity u. What will happen after that?
So the ball will fall down from the
It will fall down. Will it fall down like vertically down like this? Or do you think it will follow a curved path like this?
curve path.
Okay, okay. Your voice is not clear today. Anyway, it will follow a curved path. See, for an object to fall vertically, it should either be released from rest or its initial velocity should be in the vertical direction. Okay, because gravity is downwards. You simply release an object, we know it will fall down. Or you push the object downward and then release it, then it will continue falling downward. Right? But this ball, when it reaches the edge of the table, it has a horizontal velocity. Okay. And acceleration due to gravity is vertical. As a result, its initial velocity is to the right, acceleration is downwards. It will follow a curved path. Let us discuss the mechanics a little bit. An object whose velocity is in this direction means it only has the x component of velocity. It did not have any velocity in the y direction in this case. Okay, but acceleration is downwards. So we had discussed this before. If acceleration and velocity are not along the same line, the object will not move in a straight line. Now, since the acceleration is downwards, what will happen is it will gain velocity in the downward direction. So at the next moment, situation will be like this. The object will move ahead a little bit. Just a little bit it will move. It won't even cover that much gap as I have shown in the diagram. It will have the same x component of velocity. Can one of you tell me why the x component of velocity will not change when it is falling off?
Because there is no acceleration in x direction.
Correct. Gravity is vertical, in the y direction only it acts. There's no acceleration in x direction, x component won't change. But there will be a y component developing now. As a result, what will happen? Its overall velocity will now be tilted downwards like this. An instant later, okay, assume the ball moves to this position. It will have the same x component of velocity, but now a slightly longer y component of velocity. Why? Because gravity continues increasing that component. So as a result, its velocity will be further tilted downward like this. So as time passes, the y component of velocity goes on increasing, and its velocity component, and its overall velocity vector keeps tilting towards the downward direction like this. And ultimately it strikes the ground somewhere ahead. Okay. So this case is what we are going to discuss today. Assume this height is h. So from a height h, an object is projected horizontally like this, and you all know from everyday experience that it is going to strike the ground somewhere ahead. Like this. So Pawan, tell me, Tell me a few things that you think we can derive about this object. ఏమేం కనుక్కుందాం?
Sir, range.
Okay. One thing you want to find out is the distance where it strikes the ground. Okay, that can be done. Anything else you would like to find out?
Sir, velocity of projection.
Velocity of projection మనకు తెలుసు, like that has to be given. Based on that only you have to, or if you want to find out velocity of projection, then something else will have to be given. Okay, but here to begin with, we are assuming the velocity is known, u is known, and the height from which it is falling is known. Okay, the height from which it is projected is known. What else can we calculate?
Sir, angle.
Which angle?
Angle of projection.
See,
అంటే sir, height by range కనుక్కుంటే tan theta.
that is not called angle of projection. Okay, what you are talking about is this angle, I guess. Okay, that is not angle of projection. It's just the angle made by the line connecting the initial and final points with the horizontal. But one thing we can find out is just before hitting the ground, at what angle the ball will be moving. Okay, with what velocity it moves, we can tell. Okay, I mean, we can calculate. There are a lot of other things. We can find out the time it takes to fall. And few more questions also I will tell you later. Let us start solving this part first. So there is an object projected horizontally. Assume this is the object. It has been projected horizontally. Horizontally means parallel to the ground in the x direction from a certain height above the ground. That height is known to us. And another thing we already know is acceleration. Acceleration due to gravity is known to us. Fine. Okay, we'll see how we can find out the time, the final velocity, the range and all. But tell me, is the motion of the object straight line motion or is it moving in a plane? Does the object, after falling off from the table, does the object move in a straight line or a curved path?
Curved path.
Curved path, and you can put it in the vertical plane. It is moving in a plane. And whenever you want to derive anything about motion in a plane, 2D or 3D, the first thing you have to do is to write whatever you know in the form of vectors, resolve them into components. Okay, now we know this object is going to go forward like this and strike the ground somewhere here. U is known to us, H is known to us. What we have to do first is fix a reference frame. Reference frame means you have to fix the coordinate axis with the origin somewhere. Where you take the origin is your choice. If they give you in the question, you will have to follow that. Otherwise, it is up to you. For now, what I'm doing is I'm taking origin at that point on the ground, okay, which is vertically below the point from where the object is dropped. Not dropped, thrown. Okay, this height is h. Right. So basically what happens is this is the vertical direction is now the y component, y direction. The horizontal direction is the x direction, and this point on the ground is the origin for us. There's no rule that you have to take the origin at that point. For convenience, I'm taking it there. You can take that initial point of the initial position of the object also as the origin. Nothing wrong in that. Okay. Pawan, tell me how to write initial velocity as a vector. This u is the magnitude, and you can see the direction of initial velocity. How to write it as a vector now in terms of I cap, j cap?
Sir, u x I cap.
Ux is u only, no? Unna velocity anta x direction lone kada undi. All the velocity is in x direction itself. So you take it as u I cap. Plus 0 j cap also you can write, or even if you don't write that, doesn't matter. Okay. Next thing we know is that acceleration due to gravity will be downwards. Acceleration due to gravity is g. G is the magnitude, and you know the direction. Aishwarya, tell me how to write acceleration as a vector. Its magnitude is g, direction is downwards.
Minus j cap.
Minus g j cap. So we have the initial velocity, we have the acceleration. And we know one more thing. As the object goes from this point A to this point B, it comes down by a height h. How much it totally moves, we don't know. How much is the total displacement, we don't know. How much is the horizontal displacement, we don't know. But the vertical displacement is known to us. Okay. So we know displacement in the y direction. And it is h units in the downward direction, right? So you will take it as minus h j cap. Displacement is known, initial velocity is known, acceleration is known. Okay. One of you tell me how to calculate the time taken to get here, time taken to go from A to B. You observe what is known, and what you need to calculate is time. You tell me which is the equation to use.
Sir, is it S is equal to UT plus half AT square?
Okay, that's one of the equations involving time. What is the other equation of kinematics which involves time?
V is equal to
V
U
is
plus A.
equal to U plus AT.
V is equal to U plus AT, correct. We don't know the final velocity here, so we can't use V is equal to U plus AT. So we are only left with the option S is equal to UT plus half AT square. Okay, and see, we don't know the complete displacement. We know displacement only in the y direction. So how you apply the equation is Sy, displacement in y direction, is Uy into T plus half Ay into T square. Okay, displacement in y direction is minus h. Initial velocity in y direction was 0. Acceleration in y direction is minus g t square. Okay, so you get minus h is equal to minus half g t square, minuses cancel. T square is equal to 2h by g. So t is under root 2h by g. Okay. Other than Nitya, do any of you remember seeing this expression anywhere? And in which case?
Time of descent, sir.
Time of descent. Good. In which case? Like, what is the situation? In which situation is this the time of descent?
When acceleration is constant.
And okay, when an object is dropped from rest from a height h, that condition is very important. It should be dropped from rest. Then to descend by a height h straight down, okay, to come to this point, it takes a time t is equal to under root 2h by g. Fine. And I think in ground to ground projectile also we had discussed this class or the class before that. In ground to ground projectile also we had discussed the time of descent. This part. Okay, the time it takes to go from the position of h max back to the level from where it was projected. This time is same as this time. The time taken by a freely falling body starting from rest to come down by a distance h. Okay. In fact, what we are discussing today is this half of ground to ground projectile. Okay, so the time of descent in this case and the time of descent in that vertically falling case, or the time of descent in this case where the ball is rolling off a table, should all be the same. Okay. Why are they the same? Let us discuss. Here, observe the initial velocity was horizontal. Vertically didn't have any velocity. So call these objects as x and y. Take this as x and this as y. X didn't have any vertical velocity. Y also didn't have any vertical velocity initially. and both are under gravity itself, and both have to descend the same height h. Okay, so obviously they will take the same time to come down. Why did x move in a different path? Because it had that horizontal velocity, it follows that curved path. But vertically, what happens to x is same as what happens to y. Okay, so after some time, x will be at this position, at this level, right? At that time, y will be exactly here. Because vertically, what happens to them is the same, because they both accelerate at the same rate vertically, gravity, acceleration due to gravity. When x gets here, y will be here. Okay, so by the time x reaches here, it would have gained some velocity in the vertical direction. Y also would have gained the same velocity in the vertical direction. X would have gained some more velocity in the vertical direction. Y also would have gained some more velocity in the vertical direction. So it's all the same. That is why the time of descent is the same. Okay, so the time taken to go from A to B is under root 2h by g. It depends on this height and gravity. It didn't have any velocity in the y direction initially. That's the main thing. Okay, we found out the time. Next, we'll find out, or we'll derive the horizontal range. Just a moment. So we now need the displacement from O to B. Okay, this Sy is known to us. Now we have calculated time also. Let us include that. Time is under root 2h by g. Okay. Pawan, Aishwarya, or Vanilla, you tell me, how can we calculate or derive this distance? Okay. See, range, the distance that we now want to find out, O to B, is basically the horizontal component of displacement. The total displacement of the body is from here to here. H was its vertical component. Okay, or you can say minus h, h in the downward direction. What we now want is the horizontal component of displacement. That's all. So range, horizontal range is basically displacement in the x direction. Okay. Now you all observe what is given: initial velocity, acceleration, displacement in y direction. We know. We already found out time also. Tell me a way to derive displacement in x direction. Tell me an equation for Sx.
Sir, x is equal to ut.
Okay, fine. So displacement basically is ut plus half at square if acceleration is constant. If acceleration is variable, you can't use these equations also. But we know that acceleration due to gravity is constant acceleration only. And in fact, gravity acts in the vertical direction. There's no horizontal component, so there's no ax. So ux into t, and initial velocity was completely in the x direction, right? So ux is u itself. And time we calculated already, or we derived already, under root 2h by g. That's all. Therefore, the range, the horizontal range in this case becomes u under root 2h by g. Okay. And any of these things can be asked in reverse also. Like in the question, they can give you the range and ask you to find out the height from where it falls. You can do it, not a big deal. Okay. So basically, remember, like generally how you approach physics questions is when something happens, you have to think of the factors on which what you want to calculate depends. Like in this case, if you want the range, common sense, it depends on the speed with which the ball falls off. Okay, if the ball was initially moving slowly, it will fall here itself. If it moves faster, it will fall here. If it moves even faster, it will fall here. So range has to depend on the speed with which it is projected. Okay, and also it will depend on the time that the ball has to strike the ground, and time depends on height from where it is falling. Okay, so range depends on speed and height, u under root 2h by g. Okay, let's consider one question based on all this. Okay, let's say there is a tower or a building from which a ball is projected horizontally. Let's say with a speed of some 20 meters per second. And the height of this building, take it as 80 meters. Which is the tallest building in our country? General knowledge question. Do any of you know?
I guess Statue of Unity.
It's not a building. Anyway, yeah, no, it's the tallest statue. Is it taller than all buildings? Maybe. Okay, fine. How tall is it? Okay, let it be. Like I'm just thinking if 80, I just want you to think if 80 meters is a practically possible height for a building or not. What do you think? Any one of you? Is it a realistic height?
Burj Khalifa.
Arre, that is not in our country, no? Anyway, I just want you to think if 80 meters is a realistic height of a building or not. Anyone?
Yes, sir.
Okay. It's possible. 80 meters is possible because usually one floor of a building will be about 9 to 10 feet. 9, more than 9 it will be. Okay, 9 feet is approximately 3 meters. So one floor is 3 meters. Then 80 meters is like 26 floors possible. There are buildings much taller than that. Fine. So a ball is projected with a speed 20 meters per second horizontally. You can see the angle at which it is projected. From where it is projected also you can see. So obviously, okay, directly tell me what is the time of flight? That is the time it takes to hit the ground. And what is the horizontal range? Vertical velocity is 0. So think of which formula to use for time.
Sir, is it 4 seconds?
What is the formula you applied?
2u by g.
2u by g. How do you justify that this formula can be used in this case? Like if according to you, if this speed had been 40, then your answer for time of flight will become 8 seconds. No, that is not the correct way to do it. Okay, Pawan, you also gave answer as 4 seconds, but what was, how did you calculate?
Root of 2h by g.
See, in this case, there is a formula for time of flight is equal to 2u by g, but you need to remember in which case that is applied. Okay. When an object is projected vertically upward with a speed u, then ascent takes a time u by g, descent takes a time u by g, total time of flight becomes 2u by g. It is for that case. Here, when the ball falls off like this, it is projected like this and falls this way. The time it takes to hit the ground, see, generally time taken to come down or go up depends on the y component, never on the x component. In this case, initially the y component is 0. So it's like a ball released from rest in the y direction. X direction it has velocity, y direction it was at rest. So it just has to descend 80 meters starting from rest. And time taken to descend a certain height starting from rest is always calculated as under root 2h by g. Okay, that is what we had just discussed. Okay, time of descent, time taken to go from A to B is under root 2h by g. Okay, so there is no single formula for time of flight in all cases. Case to case, you have to think of what is given to you, on what factors the time of flight or ascent or descent depends, and choose the appropriate formula. Okay. So if you substitute 2 into 80 is 160 divided by g is 10, root 16, it happens to be 4 seconds, but this is a coincidence. As I said, 2u by g is not the correct formula to apply. Because in this case, whether it is projected with 20 meters per second, as was originally given in the question, or 40 or 60 or 21, anything, it will take the same time to reach the ground. The only thing that changes is where it hits the ground, depending on the speed. Okay. Hope this point is clear to all of you. If you have any questions, you can ask. It was projected with a speed 20 meters per second. Okay. Now the range. And see, this is generally, I'm telling to all of you, don't remember formulas. Okay, because that confusion will always be there. At the end of 2 years, when you study 3 subjects, so many formulas, so many different cases, it is very unlikely that you will be able to recollect the correct formula for each question in your final exam. So visualize the situation, recollect the derivation. Okay, that's why practicing derivations is most important. Anyway, next thing we need to find out is the range. So again, don't use the formula. Range is displacement in x direction. Displacement in x direction depends on velocity in x direction into time. Okay, and it can be calculated as uxt plus half axt square because acceleration is constant, and this part is 0. How much is initial velocity in the x direction? Anyone?
20 meters per second, sir.
20. All the velocity was in x direction itself, and the time taken to hit the ground is 4 seconds. So the horizontal range becomes 80 meters. That's where it strikes the ground. Fine. So these are common things. These you will find in any book. Let us do some extra questions based on this situation. First, calculate its velocity just before hitting the ground. Do this, all of you. I'll copy the diagram. I'll write the time of flight and range also if you want. We know that the time it takes to hit the ground is 4 seconds. And we know that the horizontal range is 80 meters. The question to solve now is velocity just before hitting the ground. We know its initial velocity. We know the height by which it descends. Okay, time, range. We know acceleration also, needless to say. So can one of you tell me an idea how to calculate the velocity just before hitting the ground?
V square minus U square equal to 2s, sir.
V square minus U square is 2as you want to use. Okay. Let's see. I see nothing wrong in that. Good. It's one of the ways in which with which you can find out the final velocity. Let's see if it works in this case. So your aim is to calculate V. So you need to know U, A, and S. U is known. A is known. What about displacement? Do you know the total displacement?
No, sir.
Still, this equation can be used. How?
So like first we can calculate its x component and
Good.
y component.
Good. You apply this equation. Generally also when this equation is used, you have to use it in one direction only. Okay. So you apply this equation in the y direction. Using that, what will you get? You will get final velocities y component. And then add x component to it, you get the total velocity. Okay, good. So let us use this. There's another way also, we'll discuss that. So what we are going to do is vy square minus uy square is 2 acceleration in y direction, displacement in y direction. Substitute the values and derive the y component of velocity, all of you. Tell me what answer you get. Shouldn't take this long just to substitute some numbers. Okay, I got one answer as 20 I cap plus 40 J cap. See, 20 I cap plus 40 J cap will be this way. I don't think the ball will be moving this way finally. Okay, it's not moving at that upward angle now, just before hitting the ground. So make some correction in your answer. Okay, fine. Pawan, tell me the values. What are you substituting in place of uy?
Sir, 40 meter per second.
When did uy become 40 meter per second? Why did you take 40? Or are you
Uy का
telling?
sir, not
Okay, you are telling me the
answer.
answer. Okay, tell me what values you substituted. How much is uy?
Sir, 0.
0. Ay?
10.
See, this is one thing that will, like, in the final exam, it will hurt you. You have to be careful with the sign also. Pawan, which direction are you considering positive, upward or downward?
Sir, downward.
Downward you are taking positive, then 10 is fine. Okay, listen all of you. If you are considering the downward direction as positive, usually we don't do that. Okay, fine. If you are considering downward as positive, we know gravity is downward, so you can take it as plus 10 meters per second square. And this 80 also will be taken with a plus sign, because that 80 meter displacement is in the downward direction. So you can take Ay as 10 and Sy as 80. In case you take upward direction positive, then acceleration in y direction will be minus 10, displacement will be minus 80. Okay. But okay, let us take upward only positive. Generally, that is how we do it. Okay, let's consider the upward direction positive. Then acceleration in y direction, acceleration due to gravity is downwards, no? So it is in the negative direction, we'll take it as minus 10. And that 80 meter displacement is also downwards, so minus 80. Minus minus cancel, it effectively becomes 1600. So you get Vy square is equal to 1600. If Vy square is 1600, how much is Vy? Anyone? Square of what number is 1600?
Sir, 40.
Plus or minus 40. And which is the correct answer? Plus 40 or minus 40 in this case? I told you upward direction is positive. Based on that, you think and tell. Final y component of velocity should be positive or negative?
Negative, sir.
Negative, downwards, no? Finally, that 40 meter per second will be in this direction. It will have 40 this way. That other 20 will remain with it this way. So that is the final velocity now. Therefore, we take, since we considered upward direction positive, but the velocity is downwards, we have to take minus 40. Okay, as I said, see, there are a lot of things you need to be careful about while solving physics questions. Don't completely go formula based. Imagine the situation first. Like here, you have to visualize the ball falling down. You have to visualize its x components and y components along the way. Okay, during flight at some instant here, it would have developed a small y component, downward direction. Finally, when it is just about to hit the ground, it will have a larger y component because it came down further. That y component will increase, but everywhere during the flight, the x component will remain the same. 20. Here also it will be 20. This visualization should be done. Only then your answers will be accurate. Okay. So final y component we got and x component we know. Because gravity is in the y direction, x component doesn't change at all. Okay. So the final velocity can be written as 20 I cap minus 40 j cap meters per second. Hope this is clear to all of you. If you have any questions, you can ask. Okay. Next question, same situation. We have visualized how it falls. We found out time of flight, range. We even found out the final velocity now. My next question is to calculate the angle at which it strikes the ground. Okay, how many of you think it will hit the ground vertically? Means how many of you think it will be moving perpendicular to the ground just before hitting it? Is this how it moves? What do you say? Yes or no?
No, sir.
No. How do you justify that?
Sir, because it is thrown with some angle, it should make some angle with the ground before hitting it.
Okay, not because it is thrown at some angle. See, it has the x component of velocity, right? And that x component doesn't go anywhere. Then how can the velocity completely be in the y direction just before hitting the ground? Okay, so this is not how it hits the ground. It hits the ground at an angle like this. That angle is what you are asked to find out. Okay, so first you need to, like, generally also, not just in my class, I'm telling you all, whenever you study something, no, visualize. Okay. And here in this diagram also we can see the x component and the y component. If you put them together, this is the direction of its final velocity. Just before hitting the ground, this is how it moves. So this angle with the ground is what you're asked to calculate. Let's call it alpha. Try it, all of you. Calculate the angle alpha. It's basically a question of angle made by a vector with the x-axis. And you all know how to do it. Try to recollect and solve. Vanilla, what happened? You forgot your favorite formula. Tan alpha is equal to?
Y component by X component, sir.
And then why are you not doing it? Anyway, I told you not to go by the formula. You need an angle here. Whenever you want to find out the angle made by a vector with x-axis or y-axis, make use of its components. The idea is that the components of a vector and the vector itself will always form a right angle triangle. Okay. Now we know this final velocity vector. Observe the question. Again, this also, see, in class you'll understand everything. In exam you won't get answers because in class teacher will take you step by step. In exam they'll ask you the final step. The intermediate steps you'll have to take on your own. Okay, which most students don't know how to do. Now you are asked, what is the question? Angle at which it strikes the ground. Means you need to find out the direction in which it is moving just before hitting the ground. And the direction of motion is always given by velocity vector. When you see this question in the final exam, you may not even get the idea that you are supposed to find out the velocity vector's angle. Okay. So see, that is where most students fail in physics. They know everything. They know the theory, they know the concept, but they don't understand how to apply at the right time. So see, this is basically asking you about the direction of motion. And direction of motion depends on velocity. So you have to find out the velocity just before it strikes the ground, which we have already done. How much is it? 20 I cap minus 40 j cap. Now you just have to find out what angle it makes with the x-axis. Visualize the vector. Let's draw its components. 20 I cap will be this way. Okay, slightly smaller. Next to minus 40 j cap. This way. Then the actual vector, the velocity vector, will be like this. This is 20, this is minus 40, but magnitude wise it's just 40. And you need angle with x-axis. That's all. This is what I was saying. The components, okay, you see that orange one and the green one. Those are the components. The black one is the actual vector. Components and the vector always form a right angle triangle. And you can use trigonometry to find out the angle. That's all. You know, opposite side, adjacent side, tan alpha is 40 by 20. That is 2. So alpha will be written as tan inverse of 2. That is the angle at which it strikes the ground. Is this clear to all of you? Any questions in this? Okay. Next question, same situation. Next question. What is the speed with which it hits the ground? I am not writing the question also. You also don't need to write, think and try to answer directly. The speed with which it hits the ground.
Root 2000, sir.
Okay, how did you calculate?
The speed is velocity is magnitude.
Good. That's all. Speed is the magnitude of velocity. We know the velocity with which it hits the ground. Take its magnitude, you get the speed. Yusuf, can you tell how to find out the magnitude of a vector? Suppose a vector is written like this. Root x square plus y square. Che, xi cap plus yj cap. How do you calculate its magnitude? Okay, no response. Let it be. And we know that for a vector like this, the magnitude is root of x square plus y square. So in this case, we know velocity vector is 20 I cap minus 40 j cap. So its speed becomes root of 20 square plus 40 square, root 2000. You can simplify it. Let it be. Simplification you do. Okay. Now we know that its time of descent is 4 seconds. It takes 4 seconds to hit the ground. Means for 4 seconds it will be in flight. Let us find out a few more things about this. There are a lot of things that can be asked. Okay, it takes 4 seconds to get to the ground. Let it be. Tell me where it will be at 2 seconds and how it will be moving after 2 seconds. So the question is, at t is equal to 2 seconds, what is the, how it will be moving means what is the velocity of the object? First part. Second part, how high will it be above the ground? Now these things don't matter anymore. Total time of flight and range. Try this, all of you. I'll give you 2 minutes. Okay. One of you tell me an idea. How to calculate its velocity after 2 seconds?
Sir, we should calculate its y component because its x component is constant.
Good. Okay. See, we had discussed this in ground to ground projectile also. At any point during flight, if you want to know the velocity of the object, remember, you already know the x component. Okay, if initial velocity is known, then we know the x component throughout the flight. All you need to calculate is the y component. Okay, fine. I got one answer as v is equal to 20. See, that's not a complete answer. I asked you for velocity, no? Give the complete answer. Okay, Nitya, tell me how to calculate y component of velocity after 2 seconds. So you know the time and you need velocity. How to calculate? No answer. Okay. Pawan, tell me how to calculate the y component after some amount of time.
Sir, V is equal to U plus A2.
Okay, Vy is equal to Uy plus Ay into T. How much is Uy? Okay, fine. 0. Ay minus 10. Time is 2 seconds. So velocity's y component is minus 20 meters per second. And we know x component is 20. So the overall velocity at 2 seconds becomes 20 I cap minus 20 j cap meters per second. And once you know velocity, you can tell the speed, you can tell what angle it makes, all those things. Okay, so this part is done. Next, height above the ground. Anyone, how to calculate how high above the ground it will be after 2 seconds? Let's say it is here at 2 seconds. Tell me this. Total time is 4 seconds, right? In 4 seconds, it falls 80 meters. Then in the first 2 seconds, will it descend by 40 meters? Yes or no, and why? Total time of descent was 80. Total time taken to descend 80 meters is 4 seconds. Then in 2 seconds, will it descend 40 meters?
No, sir.
Justify.
Sir, because its y component changes.
Okay. Then in the first 2 seconds, yeah, your answer is correct only. It doesn't move with a constant velocity, so it won't cover equal displacements in equal intervals of time. So there's no guarantee that in half time, half displacement will be covered. Okay. Do you think it will fall less than 40 or more than 40? This distance that it has already descended, I'm asking. You said it won't be 40. Will it be less than 40 or more than 40? Anyone else also, if you can answer that, you can.
Sir, less than 40.
Why? Correct. Your answer is correct. Why? How did you say
Sir,
it will be
is
less?
it because the gravitation it increases as the body moves forward?
Okay, okay. I understand what you wanted to say, but what you actually said is wrong. Gravitation does not increase, velocity increases. Okay, yeah. So initially, the first 2 seconds of descent, it will be falling slowly. The last 2 seconds, it will fall faster because due to gravity, the velocity increases. So in the first 2 seconds, it will descend less than 40. Next 2 seconds, it will descend more than 40. Okay, fine. Now tell me the actual procedure. How to find out how high this object is after 2 seconds. We need this height. Pawan, you gave the answer as 20 meters. How?
Sir, v square minus u square is equals to 2as.
E square minus u square is 2as. Using that, what will you get? Yeah, it's one of the ways to proceed. What will you get using that?
Sir, height.
Which height?
Y-axis height.
Means this one.
Yes, sir.
Okay, tell me. You want to use v square minus u square is 2as to derive that. Can be done. I want to see if you did it properly or not. S is what we want to calculate. Tell me the other values. How much is v?
Sir, 20 meters per second.
Why is v 20? And first tell me, in this equation, what does v mean? What is the meaning of v in
Sir,
this
అంటే
equation?
నేను అన్ని y కాంపోనెంట్స్ తీసుకుంటున్నాను సార్.
Okay, you are taking all y components, reasonable only. So vy minus uy is equal vy square is equal to ay sy. Okay. What is the meaning of v?
Final velocity.
Final velocity. Why is it 20? And for this part of the journey, this is initial and this is final. Here the y component was 40, no? We calculated. It was minus 40. Why are you taking 20?
సార్ అంటే నేను స్టార్టింగ్ పాయింట్ నుంచి 2 ఈక్వల్స్ 2 సెకండ్స్ వరకు అలా తీసుకుంటున్నాను.
See, అందుకే అడిగినా నిన్ను. నువ్వు కనుక నీకు ఈ హైట్ వచ్చిందా డైరెక్ట్గా అని అడుగుతున్నా. ఈ ఈక్వేషన్తో ఈ హైట్ డైరెక్ట్గా వస్తుందా నీకు? Okay. So you are saying you considered this part of the journey from here to here, right? Okay. So now this will be taken as initial instant. This is the final instant. And if those are the initial and final instants, you can't tell this height directly. You'll have to do some additional calculations. Pawan, do you agree or not? No.
సార్ అర్థం కాదు, మళ్ళీ చెప్తాను.
Is that the part of the journey that you're talking about?
Yes, sir.
Huh. Tell me how you applied this equation to that part of the journey. Tell me what you substituted.
Sir, Vm 20, U0, A minus
Okay.
10.
V square minus U square is equal to 2AS. This is correct only because here the y component of velocity was minus 20. We already found out. And here the y component of velocity was 0. So we get this, and you get displacement in y direction as 20 square by 20 becomes 20 minus 20 meters. And you gave this as the answer. Pawan, what was my question?
That t equals 2 seconds where ground నుంచి height ఎంత?
Ground నుంచి height కదా, నువ్వు కనుక్కునింది ఏంది? You found out the height that it descended till then. You found out this height. You were asked this height. Now tell me how much this will be.
Sir, minus 60.
Okay. Height wise, it is 60 only. Displacement is minus 60, but height above the ground height is 60 meters. Okay. Go through this once again, all of you. You were asked to find out the height above the ground at 2 seconds. So in 2 seconds, we know from where to where the ball went. Okay, it went from A to B. So for that part of the journey, we wrote equation in the y direction. We got the height in the y direction. We got this as minus 20 meters. Then using that 20, we could tell the remaining height as 60 because total height was 80. Okay, hope this is clear to all of you. You could have used s is equal to ut plus half a t square also. In the y direction, you have to use sy is equal to, starting from a, ui is 0, time is 2 seconds. Ay is minus 10 t square. This also becomes minus 20. And I had told you one more idea also long back when we discussed motion under gravity in a straight line. When an object is dropped from rest, how much does it fall in the first 1 second? Anyone? If g is 10 meter per second square, how much does an object descend in the first 1 second starting from rest?
5 meters.
5 meters, correct. Next 1 second, how much does it descend? Or what is the ratio?
1:3:5:7.
1:3. Then how much? If 1 is 5, then 3 should be 15. So that way also you can tell directly that in 2 seconds, any object falling from rest will descend 20 meters only, including this one. Now this one didn't fall from rest. Horizontal velocity it had. Vertically it was falling from rest. Okay. So vertically it descends 20 meters in 2 seconds. The remaining height is 60 meters. Okay. One last question based on this case. There are a lot of things we found out. Just a moment. And see, remember how we are approaching the questions. All questions, I mean, not all, most of the questions, you will have to make use of the fact that you can split the velocity, the vectors into components, and only one component we are considering to answer most of the questions. Okay, so that is an important idea to keep in mind while solving questions based on motion in a plane. Be it projectile motion or just any object moving in a plane, components are very important. Okay. So we know what it does at 2 seconds, let it be. We know when it goes to the ground also, let it be. When it falls to the ground. Okay, I had asked one question. We found out velocity just before striking the ground. 20 I cap minus 40 j cap. One of you tell me, what is its velocity just after striking the ground? Or can you calculate its velocity just after striking the ground? Any answer? See, at this stage, we cannot calculate because see how we calculated velocity before striking the ground is from the moment it is projected to the moment it strikes the ground. In between, it's only under the influence of gravity, acceleration due to gravity, we know. We use that in equations of kinematics and we are able to tell everything about the object. But the moment it comes into contact with the ground, okay, the ball comes into contact with the ground exerts a force on it. Then its acceleration gets disturbed. We don't know what its acceleration will be after striking the ground. We can't tell what will happen to it after striking the ground. Okay, as of now, we cannot tell. Later on, in a concept called collisions, you will know that there are, I mean, you learn a few more things and you can tell in some cases, like by, I mean, if you are given some extra information, you will be able to tell what happens after striking ground also. But as of now, we cannot. Okay. Anyway, my question now is, all this is fine. At t is equal to 1 second, calculate the direction, I mean, derive the direction of motion of this object. Direction of motion means angle of inclination of its velocity. Not a difficult thing to do. You all know what has to be done to find out angle made by a vector. Start solving. Okay. Vanilla, your answer is correct only, but I got only one answer. Why is it taking so long? Pawan, tell me, how are you trying to solve? You
The
all are
tan
probably
inverse 1 by
tired, I understand. So you would have gone to the college, done your homeworks and all. This is too late. Okay. Yeah, tell me, what are you saying?
the tan inverse 1 by 2.
Okay, then why did you not give the answer? Fine, that is correct only.
That-
Huh.
And I type this later.
Okay, no problem. So you first have to find out its velocity after after 1 second, then tell the angle it makes. Velocity after 1 second, you can directly write u plus at, also not an issue. It's not a rule that you should always split into components. U is 20 I cap. Acceleration is minus 10 j cap. Time is 1 second. So the velocity after 1 second is 20 I cap minus 10 j cap meters per second. And if you visualize 20 I cap minus 10 j cap, this is the velocity vector. This angle is what you are asked to calculate. This is 10 units, 20 units. Tan alpha is 10 by 20, 1 by 2. Alpha becomes tan inverse 1 by 2. That's the angle it makes with the horizontal. It will be moving like this at that moment. With horizontal, that means with ground, it makes that angle tan inverse 1 by 2. Sometimes, just to trick you, they may ask you the angle made with the vertical also. In that case, you will have to tell this angle, which will be tan inverse 2 by 1. Okay, as I said, you need to be very careful while solving physics questions. It comes with practice. Okay, we'll stop here for today. Let's quickly go through what we had discussed. So we took one particular case in this class, object projected horizontally from a certain height. Okay, it follows a curved path, and we found out almost everything about that object. Remember the basic ideas. First, fix a reference frame. Consider some direction positive, some direction negative first. Then write the given values, like be it initial velocity or displacement, gravity, acceleration due to gravity, whatever it is, write them as vectors in terms of I cap, j cap. Okay. Then, based on what is asked, you apply the equations and remember this idea. The ball is projected horizontally. So vertically, it didn't have any velocity initially. So vertically, it's like an object dropped from rest. Okay, that's why I have drawn this diagram here. Whatever happens to this object falling from rest vertically, the same happens to this object also in the vertical direction. Okay. Fine. So yeah, tomorrow I'll send you all a worksheet based on this and some of the previous concepts also. Okay. Ground to ground projectile, equation of path followed by an object. Solve the worksheet. And yesterday's worksheet, I got answers from only 2 of you. In that also, that equation of trajectory was not there. First 4 questions I got answers, but after that there was a way to derive equation of trajectory in that worksheet. I had given steps also. Do it all of you and send me the solutions to the worksheet. Okay. See, it's very important. Otherwise, I'm telling you, no, you can just watch any lecture on YouTube. Most of the good teachers, they will cover all these ideas. Okay. But my way of dealing with it is that I'll teach you and you immediately have to solve some questions so that you get, I mean, one thing is these concepts will get fixed in your brain only if you revise them and apply them in questions. Next thing is in worksheet, some extra questions will be given along with hints so that you will get the confidence how to take steps towards answering new questions in the exam. Okay, that's a very important exercise. These things I think in your teachers also will teach in class. Okay, anyway, we'll stop it here for today. Go through the notes and solve tomorrow's worksheet. Next class will be on Wednesday itself. Wednesday, what we'll do, we'll just solve problems based on some more cases of projectile motion, and then we will move on to relative motion in 2 dimensions. Okay, very important and confusing things will be there in that concept. Fine, we'll continue on Wednesday. Thank you all. If you have any questions, you can ask.